Matrix multiplication. So in this one, we have to multiply matrix A and matrix B and find the answer to their product AB. So before we can decide if we can multiply this, we have to check if this multiplication is defined. Okay. So matrix multiplication has a rule. Two matrices can only be defined if their dimensions have this pattern. Okay. If the first matrix dimension is n by p and the second matrix dimension is p by m, this inside numbers must be the same, and then your result A times B will have this outside numbers as their dimensions. It will be n by m. Alright, so in order for matrix multiplication to be defined, this inside number over here and this number over here must be the same. We know that the dimension is the row by column. So if you think about it, the number of columns of the first matrix must be equal to the number of rows of the second matrix. Alright, so just write out their dimensions and see if the inside numbers are the same. If they are the same, then matrix multiplication is defined, and the solution or the product, the answer, will have the dimensions of whatever these two outside numbers are. They can be same or different, it doesn't matter. Okay. So here the dimension of the first matrix is 2 by 2, 2 rows and 2 columns. And the dimension of the second matrix is also 2 by 2, 2 rows and 2 columns. So since the inside numbers, we want to call these two, they're the same, my solution will have a dimension of whatever comes outside. They can be same or different. It won't always be the same as the inside numbers. Okay. So my matrix AB will be, the solution will be a 2 by 2 matrix. So I can leave space for a 2 by 2 matrix like that. So that just means that I will have 2 rows and I will have 2 columns, column 1 and column 2 in here. So my first element in this product is given by multiplying the first row with the first column. The second is given by the first row with the second column. And now to get the second row, we multiply the second row with the first column and the second row with the second column. So this is how you get the answers to each one of these elements. So let's see how we can actually get the solution to this. So to get my first element, I have to take the entire first row and multiply it to the first column. So my first row, I have 2 and 3, and my first column, I have 5, 1. So the first element here is 2, the first one here is 5. So what you need to do is multiply the 2 times 5 and then add it to the product of the next one, 3 times 1 plus 3 times 1. That gives me the first element. So if I want to write my answer here for that already, that will be 5 times 2 is 10 plus 3 times 1 is 3. So 10 plus 3, that first number will be 13. So we shouldn't write, if this is 10 and this is 3, we shouldn't write that as the two elements here. We combine them together and we write their answer as the first element. Okay, that. Alright, now to get the second element, you take the first row and you multiply it with the second column. It's like distribution. When you multiply polynomials where you distribute it to 2 of them like that. So I'm taking this first row and distributing it to the second column now. So it's 2 times 0 plus the next one is 3 times 3. Alright, so 2 times 0 is 0, 3 times 3 is 9, 0 plus 9, you get your first second element as 9. Alright, now let's try the bottom row. So the second row is 4, 1. So you have to take that and you're going to distribute it to the first column first. Row 2 with column 1. So we have 4 times 5 plus 1 times 1. 4 times 5, the first with the first and the second number with the second number. So 4 times 5 is 20, 1 times 1 is 1, So 20 plus 1 is 21. And now we take this second row and distribute it to the second column. So we have 4 times 0, 4 times 0, plus 1 times 3, plus 1 times 3. So we know that 4 times 0 is 0 and 1 times 3 is 3. So 0 plus 3, you will get 3. So this is the answer to the product of AB. Let's try another example. Let's call this example number 1. Let's try another example. Question number 2. The matrix A is given to be 4, 1, 6 and 2, 1, 1, and matrix B, let's say it's given to be 1, 1, 1, 2, 1, 3 and 0, 2, 2. So we have our two matrices and we have to find the product of these two matrices, find AB. So let's first see if we can even multiply, if multiplication is even defined in this problem. So the dimension of A is, we have 2 rows and 3 columns, so this is a 2 by 3. The dimension of B, we have 3 rows and 3 columns here, that is a 3 by 3. So since the inside numbers, since they are both the same, we can say that multiplication is defined, and my solution AB will have a dimension of 2 by 3. So whatever the beginning n numbers here, let's call them the outside numbers. Okay, the 2 by 3, that will be the dimension of my solution. So I'll have 2 rows and 3 columns. So 2 rows and space for 3 columns. Right? I'll have row 1 and row 2, and then I'll have column 1, column 2 and column 3. So how do I get these elements in each of these spaces? So the first one, I'm going to take row 1 and multiply it to each one of them. So row 1 is R1C1, R1C2 and R1C3. To get the elements in the second row, take the row 2 and multiply it to each of the columns. So R2C1, R2C2 and R2C3. So that's how I'm going to get each one of them. So let's write out the math here. Let's do the first one, which is row 1 times row 1 is 4, 1, 6. This is my first row, row 1, and this is my second row. This is column 1, column 2 and column 3. Let's write it out like that. So take the first row and distribute it to the first column. So since there are 3 numbers in each one of them, the way how we distribute it, we multiply the first to the first plus the second one to the second one plus the last one to the last one. So this is how we do it. 4 times 1 plus 1 times 2 plus 6 times 0. That is my very first element. I just got R1C1 now. So to get my, let me just write the answer below here for that one. So I get 4 times 1 is 4, 1 times 2 is 2, and 6 times 0 is 0. So now when I add all 3 of them, I get my answer as 6. So that's my first element. Now let's try the R1C2. So to get R1C2, I take the first row and I multiply it to the second column. This is my second column. So I distributed it to the first one. Now I have to distribute it to the second one. So 4 times 1 plus 1 times 1 plus 6 times 2. And we know 4 times 1 is 4, 1 times 1 is 1, 6 times 2 is 12. So 12 plus 4, 16 plus 1, altogether we have 17 as our row 1, column 2. And lastly, we take the row 1 and distribute it to the third column. So again, 4 times 1 plus 1 times 3 plus 6 times 2. So this is our column 3. We just distributed 6, the first row to the third column. So that we get 4 times 1 is 4, 1 times 3 is 3, 6 times 2 is 12. So 12 plus 4 is 16, 17, 18, 19. We got our answer as 19 here. Now we're going to look at row 2. Okay, so we're going to take the second row and we're going to do the same thing. We're going to distribute it to column 1 and then column 2 and then column 3. So let's do it one at a time. So now it's 2 times 1 plus 1 times 2 plus 1 times 0. So first to the first, second to the second, third to the third. Multiply them and add it. So we have 2 times 1 is 2, 1 times 2 is 2, and then the number is 0. So we have a total of 4. Now take this and distribute it to the second column. So let's do that. So we have 2 times 1 plus 1 times 1 plus 1 times 2. So 2 times 1, 1 times 1, 1 times 2. So that will be, we have 2 plus 1 plus 2, that will be 5. And last one, we take it and distribute it to the third column. So we have 2 times 1 plus 1 times 3 plus 1 times 2. 1 times 2. So take each one, 2 to the first, multiply 1 to the 3 and 1 to the 2. We multiply them and add their products. We get 2 times 1 is 2, 1 times 3 is 3, and 1 times 2 is 2. So we get a total of 7 here. So that is how we get the product. It is actually not hard, but it is, if we are not careful, we can make a lot of mistakes with this. So that's, we have to be really careful that we're following the order correctly. Just one last example. So I have matrix P is, and I have matrix Q as. So let's look here and see if we can multiply these. So the dimensions of P is 2 by 2 and the dimensions of Q is 1 row and 3 column. So when you look inside here, we see that these two numbers are not the same. When that happens, you cannot multiply. So you have to say that multiplication is undefined in this case. Undefined in this case. I hope that these are enough examples. So that's how we do matrix multiplication. The most important facts here to remember are that you have to first check if the multiplication is defined, and if you're beginning to learn this, if you're able to write this matrix right here, to be able to write out R1, C1 like that, if you can do that, you will be able to do this properly, and just focus on multiplying it correctly.